Hello students. After the distinction between intrinsic and extrinsic semiconductor, now we are going to differentiate between two extrinsic type of semiconductors, that is n-type and p-type semiconductor. So the first point of similarity between these two is these both are extrinsic semiconductor, but the difference is the impurity atom that we add to get these two are different. In case of n-type, we add pentavalent impurity, that is group 5 elements, while in case of p-type semiconductors, we add group 3 elements or trivalent impurity. So the first point is both are extrinsic type of semiconductors, but to obtain n-type impurity that has to be added, that impurity should be of group 5, that is pentavalent, while in case of p-type semiconductor this impurity is of group 3, group 3rd, and it is trivalent. So this is the difference between n-type and p-type. Also, the second difference is the impurity atoms that added to n-type semiconductor, to get n-type semiconductor, they provide free electrons, and that's why they are called donors. While in case of p-type semiconductor, the impurity atom accept electrons and create vacancies called holes, and that's why they are known as acceptors. So the second difference is impurity atom add free electrons and known as donors, while here in this case impurity atoms accept electrons, and that's why create vacancies, and these vacancies are called holes, and that's why the impurity atom is called acceptor. In n-type semiconductor, majority charge carriers are free electrons, while minority charge carriers are holes, as the impurity that we are adding is providing free electrons, so majority is of free electrons and minority is of holes. While in case of p-type, majority is of holes, majority charge carriers are holes, and minority charge carriers are free electrons. In case of n-type semiconductor, the number density of electrons, since they are majority, so the number density of electron is much more than the number density of holes, while it is opposite in case of p-type. In p-type semiconductor, number density of holes is much greater than number density of electrons. So this is the fourth difference. Now the last one is by the energy band structure of these type of semiconductors that we will study in the next video. The donor impurity level in case of n-type, donor impurity level lie just below the conduction band, right? Since in pure semiconductor, intrinsic semiconductor, there is no level, no allowed energy state in between conduction and valence band, but in case of extrinsic, that is present. So in extrinsic there are two types, n and p. In case of n type, that impurity level, donor impurity level, lies just below the conduction band, while in case of p type, the acceptor impurity level lie just above the valence band. So in case of p type, we have acceptor impurity, and acceptor impurity level lie just above the valence band. So these are the main differences between these two extrinsic type of semiconductors, that is n-type and p-type semiconductor. In next video we will be discussing about the energy band structure of intrinsic and extrinsic semiconductors. So for that, stay tuned and keep studying. Thank you.